Hi there. Welcome to Damage Algebra and the second devlog for forward operations. My name is Jarrett, and I have just so many updates to get through today. First things first, though, if you don't know what forward operations is, it's my latest game dev project that combines classic RTS with basically The Sims. If that doesn't make any sense, I get it. You can check out my first devlog for a much better explanation. Use the card at the top or the link in the description, then come on back. Alright, so after 3 months, what did I do? Turns out I did a lot. 17 tickets as of this recording. The first thing I did was deal with my restrictive data management system. When I first started, I made an entity class, and then each type of object had its own class that extended the base entity class. Nothing crazy. The problem is, as you add more stuff, your hierarchy kind of becomes a mess, especially when different things share some, but not all of, the same functionality. This is a classic problem with class hierarchies. To combat this issue, I chose composability over extension. The idea is that I want to build object data from building blocks at runtime, and which building blocks I choose dictates what the thing is and what it can do. Because I am composing my objects dynamically, everything is very flexible. To do this, I stole a page from the entity component system paradigm. Instead of having separate classes to represent different types, all objects in the game are now an entity. Each entity has a list of components, which are just basically data models. What the entity is, and what it can do, is determined by which components are added to the entity. Pawns have the pawn component, but they also have the pawn animation component and the pawn condition component. Food has the isFood component and the nutrition component. Each type of component is basically a Lego brick, and I can build whatever I want from them. This does make things complicated if I want to know what kind of a thing an entity is. Is this a weapon? Or is this food? Is it both? For this, I've started building out a service layer where I can encapsulate the business logic for specific features. The weapon service, for example, has all the methods that it needs in order to decide if an entity qualifies as a weapon, and if it does, to take whatever actions that weapon can take. There's also a ton of null checks everywhere now, because you're never guaranteed that an entity will have the component that you expect it to. That is annoying, but I can live with it. So far, I'm actually pretty pleased with the flexibility. To make life a little easier, I actually made the entity into an interface that I can reference everywhere that an entity is expected. I implemented this interface in a POCO, which is a plain old class object, which is normal, but I also created a scriptable object version. All the scriptable object does is encapsulate the plain old entity object, and it proxies all the calls down into that plain object. But now I can have a saved, referenceable entity configuration. And these scriptable objects can be inserted anywhere the plain old class object can be inserted. This is great for making templates of objects, which we'll see in a bit when we get to spawning objects, and also for creating test objects that I can reuse and keep around. It's a really simple change, but it made my life a whole lot better. Next, I had to fix something in my goal-oriented action planning, or GOAP, system. I suspected it was building overly complicated plans. Unfortunately, getting any information out of that system was very difficult. So first, I built a plan inspector using Unity's graph editor functionality. Now, Unity doesn't suggest that you use this. They say it's really more proprietary and it's probably going to go away. But it does work if you're willing to do a lot of Googling and experimenting. Also, man, is it pretty. Once I got my inspector running, I could see that the plans were definitely overcomplicated. The problem was that the planner was planning from the starting state towards the goal state, and that there were many paths that you could take to the end where half the stuff you did didn't actually make a difference in achieving the specified goal. If I asked a pawn to eat some food, they would go grab a weapon first, and then they would go eat the food. Yeah, that satisfies the goal, but it's not a very efficient plan. And I know each activity should have a cost, and the cheapest plan should not include extra steps because it's more expensive. Yes, that is true, but I am nowhere near the cost tuning stage in development. So instead, I thought if I rewrote the planner to plan backwards, meaning it would start with the goal and then work back to the starting state. That would be much more efficient because it wouldn't consider anything unless it actually impacted the goal state in some way. Having spent about a month doing this, I can tell you two things. First, that so far my hypothesis appears to be accurate. The plans are much more efficient, even without tuning the costs of the activities. Second, I do not think it is wise to share how I got all of this working. Given more time and energy, I could probably do a much better job, but I think I've built an eldritch abomination, and I would not recommend anyone try to retrofit their forward planner into a backwards planner without starting from scratch to do exactly that. My implementation works, but it is god-awful. All of that said, I feel I've hit an important point with my goal planning system. Good engineers should always be reevaluating their decisions, weighing the costs of building their own systems, or using libraries built by others. I set out to build my own planning system because I wanted to learn how it works, but I feel I've accomplished that mission. So now I have to ask myself if continuing to build my own system is really the best choice. If I'm not in the learning phase, then I need to transition into the getting things done phase. And bringing in a third-party library may be the right choice now. With that in mind, I think next quarter I will probably experiment with incorporating Crash Go9's GOAP library into the game, see if I can gain any efficiencies. Unfortunately, that means you will have to wait for the next devlog to see how that went. These were by far the biggest system changes that I made in the game, but there were plenty of new systems and smaller changes that I made to existing systems in order to give soldiers a couple more capabilities. The first capability I added was to issue direct orders to your pawns. It's nice that they can plan on their own, but sometimes you want them to do what you need them to do when you need them to do it. Each command is a scriptable object that includes a method to check to see if it's even allowed to be executed, and a method to execute it. When I add the command to the list for pawns and right-click a pawn, each command on the list will check if it applies. It only shows if it does. I can then select the command I want from that list. With the ability to issue commands to pawns, I thought it would be nice to give the pawns more to do. So next, I gave them the ability to equip individual items. Thanks to the new entity system, it was really easy to add entity templates for things like helmets, backpacks, weapons, so on and so forth. Thanks to my dev action system, spawning these items in-game was also super easy. Now I can spawn an item, select a pawn, right-click on the item, and select Equip from the menu. Pawn will interrupt its own plan and try to come up with a new plan to achieve the new order. Once they pick the item up, they'll attempt to equip it if it's actually equipable. Where an item is equipped on the pawn depends on what data components I had added to the item itself. Next, I wanted to be able to switch the soldiers between their current state where they have full autonomy and a state where they act only on the orders that I give them or some other limited set of goals. Essentially, I wanted to configure the planner to be in either a deployed or an autonomous mode. If you stand the soldier down, then they'll just go back to worrying about eating more than they will fighting. There's a couple of other things I needed to add to make all of this work. First, there's a faction system that allows pawns to identify us versus them. Factions are entities like everything else in the game, just with the faction component. Pawns can identify what faction they belong to because they have the faction alignment component. There's also a system for managing what squad the soldier belongs to when they get deployed. Because your soldiers will be organized into teams and squads, and you'll be issuing orders to those groups, deploying a soldier should deploy their whole squad. This might seem unnecessary, but being able to dynamically spawn an object with its own behaviors that can then manage what the individual soldiers within that squad are doing is a crucial system that will become way more important later. Now that we have a faction system and there are enemies that can be spotted, I gave pawns the ability to spot enemies. I've adapted a system that Sebastian Lake published a video on, and I'll put a link to that video in the description below. Basic idea though, is that each tick, the pawn will find all of the pawns within range of their vision. Then they'll filter out any pawns that are beyond the field of view, meaning too far to the left, too far to the right, or behind them. Finally, it will check if there are any obstructions blocking their line of sight to the pawns that are within that field of view. Overall, it works pretty well, and our pawns can now spot enemies, so that's great. Of course, now that our soldiers know there are enemies out there, we would like them to fire their weapon at those enemies. The rifle is an entity with components on it that provide configuration information like which muzzle flash animation should show, or what shell casing particle should be ejected when the shot is fired. The rifle can also spawn a projectile entity that has its own components that dictate its own behavior. Because the projectile travels so fast, I actually can't depend on collisions. So instead what I do is every frame raycast ahead of the bullet about as far as the bullet is going to travel in the next frame and see if it will hit something in that next frame. And if it does, consider that frame that it's hit something and process that hit. This is also the first introduction of sound, which is very much a work in progress, and I'm not going to go into it now. I've worked with sound in Unity in the past, but I'm very bad at it. I have a lot of learning to do before I consider this anywhere near done, and certainly before I feel like I can speak intelligently about it in any way, shape, or form. So, not this time. So yeah, after about 3 months worth of additional work, we've got soldiers that can eat food to satisfy their hunger. They can equip items like a helmet, a backpack. They can equip a weapon. They can be ordered to do things. You can have them deployed, in which case they will spot enemies, and if they do so, they will fire on those enemies. So that's not too bad for a hobbyist working in his spare time. In any event, that's going to be it for this devlog. There's a couple of other minor things, but this video is already way too long. I appreciate you sticking with me, and I hope that you're finding this project to be interesting. As always, if you have any questions, please drop a comment below, and I'll do my best to get you an answer. If you're interested in seeing more, I'd love to have you as a subscriber here at Damage Algebra. But either way, thanks for watching. I hope to see you in the next one. Take care.